So to do the synthetic division, we just put 2 in the box from the 2 that's here, and then it's 2, -5, 7, -6. We're not missing any terms. And so then you bring down the 2, multiply, add, multiply, add, multiply, add. And so that now is, since this is an x cubed divided by an x, our answer should start with an x squared. So that's 2x squared minus x plus 5 with a remainder of 4. So we can put 4 over x minus 2. And that is the correct quotient from the division problem. Okay? So that took less than a minute. So once you get the hang of the synthetic division, these should be pretty quick. And then the next one, we're going to have -3 in the box, 1, -2, 3, -1. Bring down the 1, multiply, add, multiply, add, multiply, add. And so our answer then is x squared minus 5x plus 18 minus 55 over x plus 3. Any questions on those? Yes, Kiana? Yeah, that's if you're dividing by a binomial of the form x minus a. That's the only time you can use synthetic division, if you're dividing by x minus a. So that would include things like x plus 4, x minus 3, x minus 7. Anything of that form you can use synthetic division. If it was a 2x plus 5, we can't use synthetic division for that. If it was an x squared plus 2, we can't use synthetic division for that. It has to be of the form x minus a. So if you have something like 2x plus 5 or x squared plus 2, what do you have to do? Long division. Okay, you have to do long division. All right. For problem number 2, I just expect you to plug in 2 in place of all the x's, so that would be 2 times 2 cubed minus 5 times 2 squared plus 7 times 2 minus 6. When you do that with a calculator, what do you get? 4. Okay? And then this one is going to be -3 cubed minus 2 times -3 squared plus 3 times -3 minus 1. And what do you get? -55. Did anyone see a relationship between the answers in problem 2 and the answers in problem 1? What do you see, Chloe?
It's the remainders.
That's right. In this one, we look at our original problem. We divided by x minus 2. In problem 1a, we divided by x minus 2. And what number did we put in the box? 2. Out here we put 2. The remainder we got at the end was 4. The answer we get when we plug 2 into the polynomial is also 4. So that means plugging in a number like a into a polynomial, you're going to get the same answer as the remainder when you divide by x minus a. Okay, so plugging in 2 is the same answer as I get when I divide by x minus 2. It's the same remainder that I get when I divide by x minus 2. Okay, we see the same thing in both of the b's. Here we divided by x plus 3, so we put minus 3 in the box. When I plug negative 3 into the same polynomial, I get negative 55 as my answer. Negative 55 was also my remainder when we did the division. So that means in the future, when you're trying to evaluate a polynomial at a certain number, it might be faster to just do the synthetic division, because in synthetic division you don't have to raise anything to powers. So it's a lot easier to do in your head. I was able to do problem 1A and 1B without using a calculator. But problem 2B you could do without a calculator, but the numbers got pretty big. It might be easier to just do the synthetic division. Question, Emma?
Why do you put the remainder over like x minus 2?
It's just like when you're simplifying a fraction. So, for example, if you had the fraction 7/3, how do you write that as a mixed number? Good. That's 2 and 1/3. Why did you put the 1 over the 3? The remainder was 1, right? So when you do 3 into 7, it goes in twice. You have 1 as a remainder. So we don't say 7/3 is equal to 2 remainder 1. That's not a number. We say 7/3 is equal to 2 and 1/3. Okay? So we do the same thing with the polynomials. Instead of writing a remainder of instead of saying remainder negative 55, it's the same as saying the quotient is equal to this polynomial plus 5 divided by the original dividend. Okay? So it's just like we do with numbers. 7/3 is 2 and 1/3 because the remainder is 1, and then we put it back over the original denominator. Okay? So we're doing the same thing. All right? So now we've seen in these two examples that we can do substitution using the synthetic method. So if I want to, if I have this new function f, go ahead and everyone write down this new function f. Okay? Now there's two ways to evaluate this. We could just plug 2 in place of all the x's, but let's use our new method. We found out that we can also find the value of that function just by doing synthetic division. And so f of 2 is just going to be the remainder that we get when we do synthetic division. What number should I put in the box? 2. You put the same number in the box, 2, and then it's 5, negative 7, 2, 5. Bring down the 5, 10, add, 6, add, 16, add. We get 21, so that means f of 2 equals 21. That might be easier than trying to plug 2 into that polynomial, especially when you get into larger numbers and larger powers, larger exponents. The synthetic division never involves exponents. We never have to raise anything to a power. All we're doing is multiplying and adding. So that tends to be easier to do in your head. Okay? If I want to know f of negative 2, I put negative 2 in the box. 5, negative 7, 2, 5. 5, negative 10, negative 17, 34, 36, negative 72, negative 67. So that means f of negative 2 must be negative 67. Okay, for the same polynomial, go ahead and calculate f of 4 using the synthetic method. Okay, you should be able to do the synthetic method without a calculator. And then once you get your answer, then try it the old way. Plug 4 in using your calculator. 5 times 4 cubed minus 7 times 4 squared plus 2 times 7 plus 5. So check your answer on your calculator, see if you get the same thing. So do the synthetic method without a calculator, and then check using the plug-in method with your calculator. Okay, so I got 221 using the synthetic method, and then if you wanted to check that and see if it's right using your calculator this time, you could do 5 times 4 cubed minus 7 times 4 squared plus 2 times 4 plus 5. And you will see that if you type that in exactly like that on your calculator with the parentheses, you'll get 221 also. Okay? So now, from now on, you have 2 ways of evaluating a polynomial at a certain number. You can either use the synthetic method, which typically doesn't require a calculator, or use the plug-in method, which does require a calculator in some cases. Any questions?